Pancreatic cancer is the 14th most common cancer, but the 4th greatest cause of cancer death. It starts in a very silent way, and mostly people don't know they have the cancer there until it's too late. Here at the Colling Institute on the Royal North Shore Hospital campus, the CanSur Foundation has been concentrating on pancreatic cancer research. In this short film, we will tell the story of what the CanSur Foundation is doing with the funds that it's raising, and how its work over the last 12 years has resulted in some promising and effective outcomes. How does your team fit into the overall Colling Institute?
Well, we're a small group on this level of the Institute. The Institute is set up so that all the fantastic equipment that it has is able to be shared by all the different small groups. As you can see on our laboratory space here, Matthew's working on proteins at the moment. Over in the corner we have wonderful proteomics equipment. In this other corner over here we have a confocal microscope, which is a state-of-the-art microscope to see how proteins and antibodies are working inside cells, and there's so much else around. Pancreatic cancer is really difficult. The cells are wild, and we have to tame these wild cells, and we're learning about what makes them wild. The pancreas is a soft organ which lies behind the stomach. It's shaped a little bit like a fish, and from its mouth it releases digestive juices into the small intestine, where it breaks down food into small components to help absorption. The pancreas also makes insulin, which helps metabolize the food after it's absorbed. If you don't have insulin, you become a diabetic, which is a serious condition. People often ask, why did I get pancreatic cancer? We don't know the answer to that question for an individual patient, but we do know that people who are obese and don't exercise, people who eat a lot of junk food and not enough vegetables have increased risk. Smoking increases the risk threefold. There are lots of other potential reasons, genetic abnormalities, exposure to different chemicals, but these are things you can't do very much about.
It is a silent, deadly disease. I was fortunate because I was diagnosed so quickly.
In Australia, 2,000 to 2,500 people are diagnosed each year with pancreatic cancer, and that's roughly 5 to 7 people every day.
Professor Smith said to me just before the operation, would I give permission for tissue and blood samples, etc., to be taken and used, and my records and things like that, to be used for research and that type of thing. And I said, of course, I'm very, very happy.
Having the tissue and blood from patients like Mark is very useful to us. The blood is divided into two, serum and blood cells, which are stored for future use. The tissue is divided into two. One part is stored and the other is treated as fresh tissue in the laboratory, where it is grown to test with different medications.
So this is the tissue bank at the Colling Institute. On my right, we have nitrogen tanks with tissue samples kept negative 180 degrees. And on my left, there's industrial freezers that keep tissue samples at negative 86 degrees.
The tissue and blood samples we collect are used in the three major aspects of our research. The first of these is developing the potential for the protein ApoA2. The second is to develop personalised medicine. And the third is the development of new combinations of treatments for pancreatic cancer.
As we know, pancreatic cancer is a disease that often presents late, and a substantial number of patients are often not amenable for treatment by surgery. And I think that the next challenge that we face is to improve the detection methods of pancreatic cancer. One of the most promising and exciting things I'm working on here is investigating the role of the protein ApoA2 as a potential biomarker for the early detection of pancreatic cancer. This was discovered in our protein lab by examining serum samples in a large number of patient profiles.
Yes, this is serum. Yep.
This is serum. So we are going to look at the protein expression profile for those patients. So the serum sample on the spot, we're going to load on the mass spectrometer. This is called the CLD. And by using this CLD machine, we can see the profiling of the protein in the serum sample. As we can see as an example here, top two is patient's samples, and then bottom two is healthy volunteers' samples. We identified as ApoA2 is a lower expression in cancer patient and a higher expression in healthy volunteers samples, which is we can use as a biomarkers for the pancreatic cancer.
Our work has shown that ApoA2 carries fat, that is lipids, to cancer cells in preference to other cells. And being a transporter, we can transport new treatments to cancer cells like a Trojan horse, thus releasing the treatment inside the cancer cells, but not in normal tissue, so that patients don't suffer the complications of cancer treatments.
All this work on ApoA2 runs in conjunction with the CanSur Foundation's research for personalised medicine.
Cancer patients are frequently given treatments which are toxic and yet not very effective. Now, in our lab, Aichen has developed a method for growing the tumour and testing it against different treatments.
I've been working on very promising model. We grow patient tumor in mice. So the tumor from the patient undergoing surgery, we implant the tumor under the mice kidney, let them grow 4 weeks. After 4 weeks, we treat mice with saline or anti-cancer drugs. By end of 8 weeks, can say the tumor treated by saline is bigger than the treated by anti-cancer drugs.
The method that Aichen has developed in the laboratory grows a tumour and tests it in a period of 8 weeks. This work has been designed so that the result is available for the oncologist at the time when treatment decisions are being made.
The third research aspect CanSur Foundation is working on is finding better combinations of drugs to stop cancer growth, because the ones used to date rarely cure pancreatic cancer.
So this is my ongoing 3-year PhD project, and in these 3 years I'm examining the role of combining different targeted therapy in pancreatic cancer to overcome resistance. Unfortunately, the role of targeted therapy is quite limited in pancreatic cancer. Part of that reason is that pancreatic cancer is very disturbed in its genetic makeup, and there's also multiple redundant pathways that pancreatic cancer can escape to should one pathway be inhibited. It's kind of like Tokyo Metro, where if you have one line that's broken down, you just walk 500 meters down the road and you find another train. So here we're showing a migration assay which artificially tests the ability of cancer cells to spread around the body. In the top left corner, we are showing you the cells under normal conditions. And here you can see that after a scratch has been made, the cancer cells quickly come together. In the top right corner, we're showing you the cancer cells in response to single treatment. And you can see that the edges come together very slowly, creeping in, but never really touch each other. In contrast, if we apply double treatment together, we can see that the edges of the cells virtually hasn't moved. Essentially, the double treatment has stopped the migration process altogether. This implies that the double treatment has the ability to stop cancer cells from moving altogether and spreading around the body. Now, our ongoing project is actually to look at any biomarkers that can predict in advance whether a patient would respond to a particular treatment, a particular targeted treatment. And if we can do that, we will be able to personalize and tailor chemotherapy and targeted therapy to these patients.
So we're really fortunate to be able to work within this facility, and as you can see, there's some wonderful people here, some wonderful things being done, and we hope we can use this capacity to help people with pancreatic cancer. And I'm so thrilled actually with the things that we're doing.
As you can see from this groundbreaking research, the CanSur Foundation is making significant gains in the battle against pancreatic cancer. Their personalised and targeted treatment approach is currently showing significant success in animal models. The next stage will be the move to clinical trials. Please join with me in supporting this important work as we move forward in the search for a cure for pancreatic cancer.